Hello, my friends. Welcome to Origins. It's great to have you with us today. My name's Don Chapman, and it's my privilege to be your host. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. Our guest today is Dr. Robert Carter. Dr. Carter has a PhD from the University of Miami in Florida, and he is a geneticist. And today, Dr. Carter, we're talking about mutation malfunction. That doesn't sound good. Is that good or bad?
Actually, it is bad.
Yeah. As I look at my notes, it's kind of ominous.
It is really ominous.
Yeah.
Most people think that we're getting better over time.
Well, see, I'm in that camp. My parents have lived longer than my grandparents. And function pretty well. So people live longer. I think every generation seems taller and bigger. My kids are bigger and stronger and look healthier than me. Where's the problem?
The problem is that evolutionary theory predicts that we should get better over time.
Yes.
And when we look around the world right now, we see people living longer and being healthier and stronger. But really, the reason people are living longer is because of modern medicine and better nutrition, because we've learned a lot about nutrition. But really, our maximum lifespan is not increasing. It's just more people living to be older. We've cured childhood diseases, and the thing that used to kill people at 50, now you die when you're 70 instead.
Right.
So the average has moved up. But really, if we had this medicine and we applied it to people 2,000 years ago, and what we know about nutrition, we gave it to them 2,000 years ago, they probably would have been more robust than we are now.
Huh.
But inevitably, the accumulation of malfunctions, mutations, are going to overwhelm us. I'm going to base a lot of this off of work from other creationist geneticists.
Okay.
I'm actually going to pull heavily from one particular book called Genetic Entropy and the Mystery of the Genome by John Sanford. So here's a quote from Genetic Entropy from a man named Muller. And he's writing this back in 1950. He's one of the founders of population genetics. He says, he's warning us that, that the mutation rates have to be low, or will eventually go extinct. He says it becomes perfectly evident that the present number of children per couple cannot be great enough to allow selection to keep pace with the mutation rate of 1 out of every 10 children. So he's saying that because human females can only have so many children, if 1 out of every 10 children is born with a new mutation, we're in big trouble. He says, to make matters worse, if you, or the mutation rate, should be anything as high as 0.5 or 1 out of if every other child has a mutation, then our present reproductive practices would be utterly out of line with human requirements. If the mutation rate should go above 1 out of every 2 children, then the amount of selective elimination required, the number of people that would have to die to get rid of those mutations, would be greater than the rate of effective reproduction of even primitive man would have allowed. Genetic composition would deteriorate continuously, while the population would meanwhile diminish in numbers all the way to the point of disappearance.
Okay. Now, I hear a lot of evolutionary theory in there. How does that apply to us as creationists? Actually,
it applies very nicely because we can take, this is some of the foundations for modern evolutionary theory. It's 50 years old. But this is very mathematical when you dig into this man's work. And when we look at their mathematics and we say this is the worst case scenario, and then we look at today, we find out that the worst case scenario back then was nothing compared to reality.
Because we have a far more extensive database than Mueller had.
Yes, because we have a lot more knowledge.
A lot more knowledge.
The reason why mutation rates are so critical, because most people don't die for natural selection. Most people don't die because of their mutations. They die because they get hit by a bus or they die in war or some natural catastrophe of some sort. Most death is random, has nothing to do with natural selection. So if you look at a population of people, here's 10 people. Well, 2 of those people die in a war. 2 of those people die from accidents. 2 of those people might not ever have children. That guy on the right with the red face, he is a mutation that natural selection has to eliminate. But then those 3 people that are left, they have to reproduce enough so they at least have 10 children. Oh, but what if it gets higher than that? What if there's more people? Well, here we got the 2 people that die in the war and 2 people that die in accidents and 2 people that don't reproduce. All of a sudden, everything that's left, all those people have mutations. It'll every generation, in this case, will have more and more mutations than the generation before. That's not what evolution has predicted. It's not what's supposed to be true. And what we find out in reality, it's not one mutation for every 10 children. It's at least 100 mutations per child.
Oh my.
100 spelling errors. You have a genetic dictionary. It's called the genome. It's 3 billion letters. There's 100 spelling mistakes every generation in every person. So there's 6 billion people in the world today. That's 600 billion mutations in this current generation, alive today. And there's only 3 billion letters in the genome, which means that every possible mutation has occurred in this current human population at least 200 times, conservatively. Now, sure, there's a lot of people in the world and those things are spread out, but this can happen again the next generation, and the next, and the next, and the next. And natural selection is not going to be able to eliminate them without doing a lot of damage. Now, to explain to the audience, I'm talking about mutation. What is a mutation? It's just a spelling error. But where do they come from? Well, radiation is a classic cause, right? You don't want to spend too much time out in the sunlight because the ultraviolet light will mutate your DNA. You might get skin cancer. And people worry about atomic bombs and things and radiation and cancer and other damage. But really, most mutation comes from chromosome copying. You have a few trillion cells in your body. Your body started off with one cell. So that cell had to divide, and those cells divided, and they divided and divided and divided trillions of times. It's estimated that every time a cell divides, the little molecular machines that reproduce the DNA to make copies of it, they make about one mistake. So you have trillions of mutations in your body. After fertilization, the female embryo divides about 22 times, and the ovaries are finished, and the egg cells are inside the ovary, and they don't divide anymore. It could be 45 years later before ovulation. The egg cells are held there. They're just basically in stasis. No more division, so no more mutations. But for the man, it's a little different. Men, well, we have about 30 cell divisions before we're ready to go. And then at puberty, our cells start dividing. And they divide until we die. And if mutations are correlated to chromosomal replication, then the older a man is when he has a child, the more mutations he passes on to his child.
I see. Yeah, that makes sense.
This is data from a famous geneticist named Crow. He published this in 2000. And this is, basically he had a table, and I drew this chart from the table in his paper. A man about 15 years old having a child is going to pass on about 30 mutations. But if he waited until he was 50 before he had a child, it's estimated between 800 and 900 mutations are being passed down to the next generation. Now, we talk about mutations. We've got to ask, what's a mutation? What are its effects? Most people understand that positive or beneficial mutations are rare, and that most mutations are negative. So here's a chart. Here's a curve of possible mutations. 0 means the mutation has no effect. -1 means you die. If you have that, it's lethal. You can't survive it. +1, I put a question mark because really there's no mutation that can guarantee you're going to survive. Nothing can guarantee survival. But what is reality here? How many mutations are negative compared to how many are positive? It's a good question, because if there's a lot of positive ones, then maybe evolution can work. But if preponderance are negative, that means natural selection has to kill off a lot of people to get rid of those, or we're going to go extinct. Here's Crow, 1958. Even if we didn't have a great deal of data on this point, we could still be quite sure on theoretical grounds that mutations would usually be detrimental. For a mutation is a random change of a highly organized, reasonably smoothly functioning living body. Well, he's appealing to complexity here, which is one of the things that creationists like to talk about now. This is one of the early geneticists saying, hey, wait a minute, complexity means mutation's bad. A random change in the highly integrated system of chemical processes which constitute life is almost certain to impair it, just as a random interchange of connections in a television set is not likely to improve the picture. Or our modern version, if I randomly reprogram Microsoft Windows, I can be pretty much certain that my computer is going to crash and it's never going to work again because of complexity. This is a map of all the interactions between proteins in a fruit fly. Actually, it's only about 1/3 of the proteins, and the ones with the most interactions they cut out. These dots are proteins. The lines that connect them says that this protein interacts with that protein, and usually because they fit together. One protein might be shaped like this, another one's shaped like this, and they fit together. But some of these proteins interact with 20 different proteins, and they all interact in different places, in different complicated ways. So if we zoom up on this section and zoom up again, we can see each dot is a protein, and some of these have multiple interactions with other proteins. But wait a second. If I break one of these links, cause a mutation that causes these things to not work, more than likely the fruit fly is going to die. At best, he's going to be mutated. He'll be less robust. And so we have to ask the question, if evolution is true, how do you build a system this complicated? And once it gets this complicated, how can you change it further? I don't think you can. I think this is a dead end. In fact, I think all life is a dead end. You can tweak it a little bit, but once you tweak it too much, it's going to fall apart. And the organism and the species is going to die. So here's Neil. Now this is 1986. This is a little more modern. He says, point mutations are on the order of 30 per generation. So about 30 mutations per generation. The implications of mutations of this magnitude for population genetics and evolutionary theory are profound. Oh, really? The first response of many population geneticists is to suggest that most of these occur in silent DNA and are of no real biological significance. You've probably heard the phrase junk DNA. Well, junk DNA is necessary for evolution to occur. They need vast amounts of the genome to be useless so that if mutations occur, oh, no problem, doesn't do anything. Unfortunately for that line of reasoning, the amount of silent DNA is steadily shrinking. The question of how our species accommodates such mutation rates is central to evolutionary thought. Well, this is 25 years ago. The idea of junk DNA is outdated. And for several reasons. First of all, we now know that there are multiple overlapping codes in the genome. We have a protein code, but the DNA itself has to wrap around other proteins. DNA is all wrapped up around little marbles, they're called histones. And there's a code in the DNA that says put an A here and a T here and a G here, so it'll stick to that histone protein. Huh. But that's also a region where there's another protein is coding for a protein to do something else. So both things have to be coded to the same spot. So if you make any random mutation, you might affect 2 or 3 or 4 different functions. Wow. And now, just recently, in May of 2010, a group of people finally figured out how 20,000 genes can make 100,000 or 300,000 proteins. And there's this very complex code that takes pieces of genes and reassembles them in all these different complex patterns to make all these different proteins that change over your lifetime. They're different in all your different cells. Well, if you have a mutation now in any one spot, you might be affecting 14 or 15 or 20 different proteins. Very difficult. So, this is really the mutation spectrum. Most mutations, because we're so complex, are negative. But also, most mutations are almost invisible. Oh, I have a mutation that makes this pinky just a little bit shorter than the other. Or I have a mutation that might make me 1% less efficient in my energy metabolism. Natural selection can't see those things. They're lost in the noise. And yeah, there might be a few beneficial mutations. But anything close to 0 here is so small as to be ineffective and invisible to natural selection, and that's the problem. You see, I stole this right out of the genetic entropy book. These are genes, these dots. Here's a princess sitting on top of all the peas. This is natural selection. Natural selection doesn't act on the gene, it acts on the individual. But the genes are hidden by multiple levels of interactions, because you might have a gene that does something bad, but another gene that does something that's so good that it overwhelms this one. So they only act within context of one another. And then your environment affects genetic expression. Your diet affects genetic expression. Your attitude, your spiritual and emotional state affects hormones. And that affects genes. So your attitude can affect the expression of genes. Oh, forget it. By the time natural selection is ready here to take out the individual, the genes are almost irrelevant. And so really, we have a window of non-selection. It's named after a famous geneticist called Chimeras, called Chimera's box. Anything inside that window, natural selection can't see. And that's most of the mutations. So even though they're little, even though they're just slightly negative, every generation we have more and more and more and more and more. And eventually, we're going to be in big trouble. Here's Muller, 1964. There comes a level of advantage that's too small to be effectively seized upon by selection. Its voice being lost in the noise, so to speak. An asexual population incorporates a kind of ratchet mechanism such that lines become more heavily loaded with mutation. This is a famous thing called Muller's ratchet. He's talking about asexual species like this Daphne, this water flea. There are only females in the population. And every year, the water fleas living in a pond are clones of the ones from the year before. So they don't have sexual reproduction. That means since they're clones, if a mutation occurs in this one right here, the children of that one are going to have the same exact mutation. And it just builds up over time until there's so many that they should go extinct. Well, we undergo sexual reproduction. And this helps us tremendously because our genes get shuffled, and so we can actually shuffle away some of the bad genes. What happens is our chromosomes cross over, and when we have children, we pass on a mixed version of our chromosomes to our children. But Kondrashov, 1995, after doing a study, a very interesting paper called Contamination of the Genome by Very Slightly Deleterious Mutations. Why have we not died 100 times over? A lot of geneticists are scratching their heads saying, how can we possibly survive? He said, I interpret the results of my experiment in terms of the whole genome and show, in agreement with another geneticist, that very small deleterious mutations, now deleterious is a geneticist's catchphrase, it means bad.
Yeah.
Slightly bad mutations can cause too high a mutation load. And the accumulation of these slightly bad mutations in a lineage acts like a time bomb. The existence of vertebrate lineages, people, should be limited to about 100 generations. Oh, that's scary. Now, the fact that we're still around, because there have been probably 150 to 200 generations since creation.
Okay.
We're still alive because he's ignoring the beautiful design and the error correcting mechanisms that God engineered into the genome. If God hadn't done that, we shouldn't be here today.
But the tendency's right, even if the numbers are wrong.
Yes.
Yeah.
And so, throwing noise at the solution, complexity, and all those other factors, we don't know how large Chimera's box is. But the more complicated the genome gets, the larger that box is, to the point where positive mutations can't be selected for. Because there's so few of them, they're not going to do very much. Natural selection can't see them. So much for Darwin. He depended on positive traits appearing in a population. Natural selection can't find them. But these are there, and over time, we go down and down. Here's another quote, 1999, Ira Walker and Kitely. A high rate of bad mutation, much higher than one, or was much higher than one, it's over 100 probably,
Yeah.
is paradoxical in a species with a low reproductive rate, like people. Bad mutations, or the bad mutation rate, appears to be so high in humans and our close relatives, is doubtful that such species could survive. Now this is the evolutionary geneticist saying stuff that
Right.
our lifetime is limited and they can't explain where we came from in the first place.
So
I love
instead
this
of us
stuff.
getting better and better, they're predicting our demise.
Yes.
I think we've got all of our audience wondering where this leads and exactly what are the implications. And so we're going to talk about that when we come back. Don't go away. We've got some good news at the end, and you want to stay tuned for it. So we'll be right back.
Today's guest on Origins, Dr. Robert Carter, has a PhD in marine biology with a focus in genetics. He is currently one of the senior scientists and a speaker for Creation Ministries International USA. Dr. Carter believes that the human genome is an excellent confirmation of biblical history. He continues his groundbreaking genetics research, and you can find many of his published articles at creation.com. To to contact Dr. Carter, write to Creation Ministries International USA, Box 350, Powder Springs, Georgia 30127, or call 800-616-1264.
We are back with Dr. Robert Carter, and we're talking about mutations and how they aren't very good for us.
That's right.
And in fact, it's gotten to sound rather ominous that for the whole species. Tell me some good news. Where does this go?
For right now, let's just hit a couple of more quotes from a couple of more evolutionists about how bad things could be.
Okay.
This is Lynch, Connery, and Berger, 1995. It said, as these bad mutations accumulate, there's a decline in the viability of people. The reproductive rate goes down. And this causes something that they call mutational meltdown.
Wow.
And then they say the length of the meltdown phase is generally quite short. So a lot of people ask me, well, how long do we have?
Yeah.
I have no idea.
But they're saying it's going to accelerate at the end. A meltdown means it happens rapidly.
Yes.
Okay.
So this is Lynch, Connery, and Berger, 95. They say our results provide no evidence for the existence of a population size beyond which a population is completely invulnerable to mutational meltdown. So even though there's 6 billion people in the world, it doesn't mean that we're safe just because we have so many of us. And then Higgins and Lynch, 2001. Early work suggested that the accumulation of bad mutations might threaten small and isolated populations. Here we show that the accumulation of bad mutations may also be a significant threat to large metapopulations like humanity. That's all pretty scary, isn't it?
It really is. And you agree with their work, and you really don't see, in terms of man in this world, you see this coming. It's like a freight train. It's not going to stop.
Yeah, I don't see how evolutionary mathematics is a friend to evolution.
Yes.
In fact, I think it builds our case up very strongly that our genome is young, that we are under a curse, that we're laboring and struggling under this, that things are falling apart.
It's sure consistent with Scripture.
Yes.
And it also seems to me to be a death knell to neo-Darwinism that suggests that mutations were the way we jump from species to species. That absolutely can't be, can it?
According to everything that I've been reading in their literature and everything that creationists have written, mutations do not produce good things. The 1 out of a million that might produce a good thing, well, it's overwhelmed by the million bad ones. And too many people have to die in order for evolution to go on, and not enough time has elapsed. So even in their millions of years scenario, they don't have enough time to do what they want to do. For the evolutionist, there's no hope at all.
Yeah.
But for the Christian, we have a lot different explanation for the end.
We sure do, sir.
And we're not going to be exterminated because of mutations.
That's right.
Jesus is going to return, and there will be people here, and things are going to happen.
And in God's eternal plan, this earth was always temporary, as are these bodies.
Yes.
Because we are eternal creatures, but these are not eternal bodies. When Jesus appears, we're going to be made like Him. And then we're going to become eternal beings. I mean, our soul and spirit's already eternal, but when He appears in the sky, 1 John says we're going to be made like Him, and we'll have this eternal body in heaven with Him forever.
Yeah.
And as you have there, it's not down here, it's up there where there's no death, sorrow, crying, and tears, and pain is gone forever. That's not a part of this world scenario.
That's right.
That's God's eternal plan.
That's right. Revelation 21 is a beautiful picture of the removal of the curse, the removal of death,
That's
the
right.
removal of suffering. And so all this mutation stuff is gone, and we'll be restored, and we'll have perfectly healthy bodies. I can't wait.
Mankind, genetics is showing us that mankind's stay here is temporary. But you're going to live forever, and Jesus is the way to have eternal life. It's been God's view from the very beginning that He created you. I hope today's been a wake-up call, and that now that's your worldview too. I hope you'll join me again soon here on Origins. And until then, God bless you, my friend. It's been good having you with us. Thank you, Dr. Carter.
You're welcome.
Thank you with you.
Thank you for watching this edition of Origins. To get a copy of the information presented today, you can download a PDF file of program number 1112 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1112, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.